Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 28, 2025, just yesterday. The big idea is a realistic benchmark that plugs language model agents into live tools and judges whether the agents can plan long workflows, pick the right tools from fuzzy instructions, and ground answers in actual tool outputs. The paper is titled MCP-Bench, Benchmarking Tool Using LLM Agents with Complex Real-World Tasks via MCP Servers. And as we will see later, the implications for evaluating agentic systems are quite significant. The benchmark spans 28 MCP servers and 250 tools, with tasks and scoring designed to expose gaps in long-horizon planning and cross-server coordination. Also, the authors shared the code on GitHub. You will find a full MCP-Bench framework with benchmark runners, agent executors, task sets, and 28 MCP servers. There is a quick start with environment setup, API key config, and run benchmark commands, plus model integration via OpenRouter or Azure, and a built-in leaderboard. Alright, the intro just set up why prior benchmarks fell short. Figure 1 shows the MCP-Bench workflow that links an agent to many real-world servers, synthesizes tasks, runs multi-turn tool calls, and scores the trajectory. The left globe highlights diverse MCP servers, which matters because complementary tools enable realistic dependency chains. The center stream depicts LLM-based task synthesis feeding queries to the agent. The right side shows rule-based checks and an LLM judge that convert execution traces into performance scores. Alright, Figure 1 just outlined the pipeline from servers to scoring. Table 1 now contrasts benchmarks, and it shows why a new testbed was needed. The row for MCP-Bench lists 28 domains and 250 tools, with checkmarks for MCP ecosystem support, information grounding, fuzzy task descriptions, complex multi-goal tasks, and cross-domain orchestration. Other rows lack most of these capabilities, which limits realism and planning stress. So Table 1 just contrasted benchmarks on realism and scope. Figure 2 shows the MCP server ecosystem, which quantifies both category coverage and how tool counts vary by server. The left donut highlights that media and entertainment and research and knowledge each hold 14.3%, while several smaller domains sit at 3.6%. The right bar chart ranks servers by number of tools, with BioMCP at 35, scientific computing at 26, and a long tail of single tool servers, which signals wide diversity for task construction. Okay, the prior segment described the judging procedure with shuffled prompts. Table 3 presents the leaderboard across single and multi-server settings, which aggregates rule-based checks and LLM judge axes into an overall score. Strong models cluster near perfect schema compliance, yet the spread appears in planning effectiveness and tool usage. The top overall scores go to GPT-5, O3, and GPT-OSS 120B, while smaller models like Llama 318B trail because dependency awareness and parallelism remain weak. So, two takeaways stand out. Realistic tool use is largely solved at the schema level, but long-horizon planning and cross-server coordination still lag, and the MCP-based setup gives a scalable, reproducible way to measure those gaps. The broader implication is clearer pathways for agent training and evaluation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.